So for our final talk, we have Yi Ing, and he also is mentored by Takeshi Yoku. And the title of Yi's talk is A Simple Template Matching Method for Liver Proton Density Fat Fractionation Determination by Multiecho Gradient Echo MR Imaging. Come and talk to us, Yi.
Thanks for the introduction, and I'm not going to repeat my title. It's kind of long. So proton density fat fraction, or PDFF, is a standardized MR metric of liver fat content. Its precision and accuracy has been validated against MR spectroscopy and biopsy, and it's a widely accepted imaging biomarker for fatty liver disease. Now, to reconstruct a PDFF map is actually not a trivial matter. There's a lot of math involved, but you can see that the MR signal of a GRE image actually changes due to the interactions between protons from fat and water, and it has this form which includes a sinusoidal component as well as an exponential decay component, and it's been described by this really complicated equation, and you can see that it's dependent on PDFF, basically proton density fat fraction, as well as T2 star. So traditionally, the way we generate PDFF mapping is to first acquire multi-echo sequence and multi-echo so that we can sample the curve at multiple different time points, i.e. echo times, and then we perform a nonlinear least square fit curve fitting algorithm to generate the PDFF map. And then we can drop an ROI on the PDFF map that results in an average value that you can report as the average liver fat fraction. Despite its utility, PDFF mapping is not widely available to everyone, and primarily because community radiologists out there practicing probably don't have the technical knowledge to write their own reconstruction algorithms. And also, they can turn to vendors who have streamlined power sequence and products, or outsource their processing to a data processing company outside. But both options are actually costly. Hence, we propose an alternative solution, a per ROI PDFF calculator. So this solution involves two components. One is a radiologist to draw an ROI on the GRE images itself, record it, and use it on an online calculator to generate the PDFF. And a decision, design decision that we made is we made use of this new technique called template matching. You'll see that it's very, you'll find it very familiar because it's the same technique that Ali Piraste has presented. He called it dictionary search. I call it template matching. So how does this work? So basically, we use a parameter grid of physiologically plausible values of PDFF and R2 star, and we generate a bunch of signal templates. Basically, each template telling you how the MR signal is going to behave across different TEs. Now, to use the dictionary, you'll first record all the ROI readout values into an ROI vector. And then we calculate the dot product of each template, between each template within the dictionary and the ROI vector. And because the dot product is essentially the metric of goodness of fit, you can find one that has the maximum value and then just find out which fit parameters it corresponds to, i.e. the PDFF and R2 star that you're looking for. So if all those steps sounded really complicated, basically this method is really analogous to a big lookup table. It also borrows concepts from computer science, a design concept called dynamic programming. Basically, when you find yourself anticipating that you have to calculate the same calculation over and over again, it's actually wise to just pre-calculate all the results, save it into memory, so that you then don't have to perform the same calculation again. So in order to validate the accuracy of the template matching method for liver PDFF, we conduct a clinical study to compare it to a standard nonlinear curve fitting method. This is a retrospective study including 51 patients and 91 MRI exams, 91 because they each receive an exam before and after treatment with the scan parameters as shown. And for the data analysis, we draw ROIs on a representative part of the liver, and PDFF is calculated by one using our template matching technique as well as standard curve fitting. For statistics, we analyze using linear regression and Bland-Altman analysis to compare between the two methods. So these are my results. Basically, you can see that linear regression analysis demonstrates exquisite linearity between the two methods with a correlation coefficient really close to 1, and you can see that there's very little deviation from the diagonal line. Similarly, the Bland-Altman analysis demonstrates the PDFF generated by template matching technique falls between 0.25% of the PDFF that was generated by the curve fitting technique. So I've been talking about an online calculator. So finally, I'll let you guys have a glimpse of what the final product looks like. This online calculator is available on the URL www.rtsfit.net/tmatch. And you can log in using the username UTSW, and the password is researchday. So to use this online calculator, first you have to fill in the appropriate technical parameters of the MRI scan, which will allow the web calculator to pull the appropriate library. And thereafter, you will record, copy, and paste the ROI readouts from the GRE images into the input panel as shown on the bottom left. Click Compute, and the corresponding PDFF and R3 star value will be displayed in the table on the right. A point of note is we have begun to use this online calculator in clinical practice now. Some of our scanners are not equipped with a quantification sequence, and also we use this as a backup just in case when you have acquisition or reconstruction failure. So in conclusion, quantification of PDFF by our template matching method is accurate against standard nonlinear curve fitting method. And by implementing this technique as an online calculator, we hope to bring PDFF to widespread adoption by making it easily accessible and cheap. So I want to thank my mentor, Dr. Yoku. He single-handedly came up with the idea of template matching, so kudos. And special thanks to our collaborators at the University of Wisconsin, Dr. Reeder and Diego, for being consultants for this project. Thank you.
Thank you very much, Yi. Questions? Where should we begin? There must be questions. Dr. Rofsky.
I'm just going to make a comment. I think this concept of making online tools that are independent, that are affordable and accessible to the broad population are a tremendous contribution to the field, and I credit the whole team for contributing in that fashion.
Thank you.
I think Dr. Grist had a question too.
Yeah, I agree with that statement. Maybe you and perhaps Ali could comment as well on, tell us about some of the opportunities and limitations of these cross-institutional collaborations. What have you found to be beneficial, and what are some of the obstacles in the way to making progress in this?
For one, I think both Dr. Reeder and Diego, we met them, and they gave very good insights to how to proceed and make some very good corrections. And it's a pleasure to basically work in a multi-institutional, multidisciplinary collaborations. We bring different things to the table. We have different ideas, and marvelous thing just comes out from a mixture of those two, in my opinion.
What can Dr. Rofsky and I do to facilitate more of these types of collaborations? And Dr. Linkinski says money.
That's beyond my pay grade, so I'll leave you guys to talk about it.
I was going to say, is that giving money to Bob, or is that taking money from Bob?
Did you have to do any material transfer agreements or anything like that? Was it all just providing the opportunity for you to find each other and facilitate a collaboration?
So I think Dr. Yoko came up with the idea, and so it really began as a funny story. Actually, we wanted to basically patent this technique, so we went to our intellectual property department, and they basically came back and said, actually, Dr. Rita already had a patent on it. So that's where it began, and so we said, all right, so if we can't beat them, then we'll join forces with them.
Is Tom getting the money he deserves?
So we're planning to release
Is
this
that
as
really what the question is, Tom?
This is great. Any more quick questions before we take a short break?